webinar. I am Janita Vasquez. I am the Elementary Curriculum Manager here at OpenSciEd. And joining me today are Christy Morrison-Thomas, who was one of our leads in the unit, and Sarah Stoltz, who was one of our writers in the unit, to help you go through everything that has to do with 1.3 space. So just, oh, we skipped okay, there we go. So let me tell you a little bit about what's going to happen today. So first, I'm going to tell you a little bit about OpenSciEd in case you're not familiar with us. And then Christy's going to walk us through the first lesson of this unit and really give us the inside scoop in what's happening to set this lesson off in the right way. And then we're going to take a tour of the unit storyline. The writers are going to share with us some key features of this unit, some really great things we want to highlight for you. And then I'm going to come back and talk to you about some additional resources that we have on our website. So first, OpenSciEd is an innovative nonprofit organization. We bring together fantastic curriculum developers, science administrators, teachers, and philanthropic organizations. We develop free, high-quality science instructional materials and the professional learning aligned to those materials. For the field test, we had 9 states join us, which meant that we field tested our materials with over 450 teachers and about 10,000 students. They were wonderful in giving us feedback to make these units the very best they could be. So let me tell you a bit about our elementary materials. So first, this is our instructional model. This is what we use to develop our units. That means that we start with an interesting phenomenon, and students' questions about that phenomenon help us drive the learning throughout the unit. Our units are designed to be flexible and to really be used in real classrooms. As you can see, we have 4 units per grade level. And while our units are designed with a recommended sequence, they really are built for flexibility and to be modular so they can fit best into your school context. So, like I said before, there is 4 units per grade level. In grades K2, there are 10 lessons per unit, and each of those lessons is 60 minutes. Now, in OpenSciEd, a lesson is not just a moment in time in your classroom. It is meant, those 60 minutes are meant to be scheduled flexibly within your school work week or across weeks. And our 2,400 instructional minutes come to about 4.5% of your instructional year, which means that these units are manageable and you are able to implement them along with all your other subjects. In grades 3-5, again, 4 units per grade, but we have up to 15 units per lesson, usually between 12 and 15, and each of those lessons is 90 minutes long. Again, not meant to be taught in one session, unless you have that time. But those 90 minutes can be scheduled flexibly within the week or across weeks. And at 5,400 minutes for the school year, that comes to about 10% of your full instructional time. Right, so one thing that we think is really important in OpenSciEd is to integrate mathematics and literacy into our materials. So anytime that you see math in our work is in the service of understanding the science. You will never see math for the sake of seeing math. We integrate math through math talk, math modeling, and developing data concepts. Data is where we focus our time, so you will notice that even from kindergarten, our students are planning investigations, thinking about how to collect data, collecting that data, and then analyzing that data. Again, literacy is really important to us. So, our units include a collection of student books, all created by our authors. And all those texts that we include are informational text. So that means that we're really thinking about gathering information, sharing information with students, giving them opportunities to use new vocabulary and engage in different ways of communicating. We think it is important for our students to communicate not only orally, but in writing, using gestures, and being able to draw pictures. We also offer a comprehensive assessment system, and along with the four different types of assessment that we offer, we also have many scaffolds, rubrics, and support for teacher. So now, once you gather all this data, what do you do with it? So in our materials, you'll find supports for what to do as next steps in instruction and how to help those students that still need more support or that have a full understanding and need further engagement. So our classroom materials are found, our OER version of the materials are found on our website at no cost, but we also partner with a variety of vendors that carry our certified versions, whether it be printed materials or our hands-on kits needed for instruction. And you can find more information about those on our website. So now let's get to know a little bit more about 1.3. And Christy is going to help us do that by going through the first anchoring phenomenon lesson.
Yep. Thanks, Janita. Hi, everyone. I'm Christy Morrison Thomas. I am the 1.3 Public Release Unit Lead, and I'm joined by one of our amazing lesson writers, Sarah Staltz, and together it's our great joy to help you get to know Unit 1.3 sky patterns. Unit 1.3's overarching question is, what patterns of the sun, moon, and stars can we observe, describe, and predict? Like other K-2 units, it is comprised of 10 sequential lessons, most of which are 60 minutes long. In this unit, lesson 1 is a bit longer. It is planned for 70 minutes. As we walk through Unit 1.3, we will highlight how each part of the OpenSciEd instructional model is used to support student sense making. This model follows a pathway that begins with an anchoring phenomenon, followed by investigation lessons where students gather evidence to figure things out, and then putting the pieces together opportunities to help students synthesize what they have learned so far. In Unit 1.3, there are putting pieces together lessons in Lesson 5, midway, as well as Lesson 7 and Lesson 10. This design supports students in figuring out 3 related but distinct lesson set questions. We'll start the introduction to Unit 1.3 by spending longer talking through the anchoring phenomenon lesson. In all OpenSciEd units, this first lesson introduces an interesting phenomenon or problem, provides an opportunity for students to share initial ideas and experiences, motivates students to ask questions to investigate and answer throughout the unit, and provides a pre-assessment opportunity for teachers. So our unit begins by the teacher sharing a story about when they or someone else experienced the sun shining in their eyes. The teacher might say something like, "When I was driving to school this morning, the sun was shining in my eyes. Like, it was so bright." We invite students to share their similar experiences with the sun in their eyes, as well as other sky-related experiences. Students notice that their experiences differ, suggesting that the sky is not always the same. Then we use students' ideas to decide how to gather more information about these different sky noticings, landing on using a book to connect with more experiences from other first graders. Our book is organized into 3 sections, which are the 3 sky-related phenomena we explore and figure out in this unit. The first relates to evening events that sometimes happen when it's light out and other times when it's dark out. Specifically, students in the book take evening walks past a playground. Sometimes it's light out and they are able to stop and play on the swings, but other times it's dark out and they do not stop to swing. The second section relates to noticing the moon and stars in the sky, sometimes, but not all the time. The third section describes students' experiences with the sun shining in their eyes, sometimes after they visit their local library, but not other times. While reading the book together, we pause after each of these three sections to notice, connect, and wonder. We notice or make observations using the text and images in the book, with the teacher recording these on our notice and wonder chart. Before I move on, I want to draw your attention to the check mark on this slide. This icon indicates an assessment opportunity. In Lesson 1, these are pre-assessment opportunities to gather evidence about students' initial ideas about the lesson level learning goals, which are aligned with the unit's Earth and Space Science performance expectations. After each section of the book, we also connect to and share our own related experiences with which the teacher records on our experiences chart. Spending time connecting to our various experiences with the sun, moon, stars, and sky is important for building relevance and interest among students and in helping them see science as relevant to their lives and communities. You'll notice that the different colors and sections on this sample chart correspond with the three different sections of the book and the three lesson sets in this unit. We also invite students to ask questions about what they notice in the book and about their own and other students' experiences. These are recorded as wonders on the Notice and Wonder chart. Again, you can see the three different colors and sections corresponding to each of the book section and unit lesson sets. Then, we encourage students to record and share their out-of-school experiences with different kinds of sky-related phenomena using this community connections sheet. This connections sheet is returned and used multiple times throughout the unit in order to make connections to students' out-of-school experiences. Let me pause again for a moment here to point out the student activity icon, which shows an individual activity on this slide. You will also notice icons for whole class and pair work in this lesson. Other lessons also organize student work into small groups. Next in our lesson, we pause to review the different kinds of questions that we have generated and recorded on our Notice and Wonder chart related to these three different phenomena. How evening events, like an evening walk, can happen when it's bright out and when it's dark out. How the moon and stars can sometimes be observed in the sky, but not all the time. And how the sun sometimes shines in our eyes, but not all the time. Through discussion, we decide which of our questions to address first. We decide to pursue questions about the sun first, co-constructing this lesson set question. How can the sun be in my eyes sometimes, but not all the time? This question will drive our work in lessons 1 through 5. We decide that we can get started right away by going outside to find the sun in the sky. We co-construct this lesson question. Where is the sun in the sky today? And answering this question drives the rest of our work in lesson 1. If your class schedule provides about 30 minutes for science time, you would likely pause the lesson here and pick up with the next Explore on your next science day. Especially if we're continuing science on a new day, we recall that we're trying to figure out our lesson question. Where is the sun in the sky today? As a class, we co-construct an investigation plan to address this question. Like the 1.2 sound unit, this sun investigation plan serves to scaffold students in planning and carrying out investigations, and they will return to and revise this plan as they engage in investigations throughout the unit. As shown in the sample Lesson 1 sun investigation plan, we decide that we should go outside, find the sun in the sky, and draw and write our observations so that we can remember them and share them with others. We are introduced to sun safety goggles, which are eclipse viewing glasses that we need to wear for safety to protect our eyes anytime we are looking at the sun in the sky. We prepare to go outside to make and record observations of the sun in the sky. We will use this handout to draw, label, and write our initial observations. Know that there are a lot of supports in Lesson 1 in the form of teacher references and callouts that will support you in identifying a consistent space outside where you can make observations of the sun in the sky, as well as support for taking students outside so they can make such firsthand observations. While we're outside making and recording our observations, the teacher has an opportunity to talk with students, asking questions like, where did you observe the sun in the sky? How did you record that? Such questions enable teachers to begin to determine the kinds of support students may need in upcoming lessons as they continue to make, record, and compare observations of objects like the sun in the sky. After making our observations, we all point to the sun in the sky and note that we are all pointing to the same location. Back inside, we brainstorm ways we could make everyone's ideas and observations of the sun visible to the whole class, and we decide to make this sun observations chart. We use sticky notes to represent where we recorded the sun on our own handout. And this is a sample of what our initial sun observations chart might look like. We notice that our sticky notes are all over, and we discuss how this doesn't make sense because we all observed and pointed to the sun in the same location. We realize that right now we can't use these recorded observations to decide where the sun is in the sky today. So we brainstorm ideas for what we could add to our sun observations chart to help us show the location where we notice the sun in the sky. And we decide to add objects on the ground, like our playground, some trees, maybe the roof of our building. With students' input, the teacher adds these ground-based reference points. Then, students are able to reconsider where they should show their observations of the sun in the sky. Eventually, we remove all of our sticky notes and add the sun to our chart in an agreed upon or consensus location. We want to point out how this instructional decision was intentional. We want students to experience this initial unsuccessful attempt to compare recorded observations because it motivates for students a need for attending to ground-based reference points when making observations of objects in the sky. These experiences position students as the drivers of the unit, making decisions about what to do and how to do it. This builds students' understanding of how to plan for and carry out scientific investigations. We end this lesson considering whether or not we think we have observed the sun anywhere else in the sky. We decide to make a prediction about where we think we will see the sun in the sky in the morning of our next science lesson, and we use a predictions sticky note to show that spot on our sun observations chart. These predictions will drive our next investigation. So, to summarize Lesson 1, the anchoring phenomenon lesson, we read a book to generate noticings and wonders about and connect to our experiences with sky-related phenomena, including evening walks when it is sometimes light out, how we sometimes notice the moon and stars in the sky, and how the sun is sometimes in our eyes. We use these to start our class notice and wonder chart and our experiences chart. We go outside to make and record observations of the sun's location in the sky. We compare our observations posted as sticky notes on our sun observations chart and decide we need a common ground-based reference point. We add those reference points to our sun observations chart and record a consensus observation of the sun in the sky. And then we end the lesson making predictions based on our prior experiences and initial ideas about where the sun will be in the sky on another science day. As we prepare to move on in our Getting to Know Unit 1.3 webinar, we want to note that an integral part of the storyline instructional model is navigation, deciding together between steps what we need to do next, so the unit is coherent from the student's perspective. This way, the class has a shared mission to figure things out, and the sequence of work in the unit helps them make progress on answering their questions. If someone were to ask a student, "Why are you doing that today?" they should be able to connect back to their own questions about the phenomenon. Well, we're trying to figure out how the sun is in our eyes sometimes, but not all the time, rather than just, well, my teacher said this is what we're doing today. So let's tour the rest of this unit by lesson type and see how the lessons are connected. Most of the lessons in a storyline unit are investigation lessons. Through investigation lessons, students engage in science and engineering practices, collaborate to create a plan of action, and the teacher provides students with space to grapple with, figure out, and make sense of science ideas. The instructional model graphic here loosely follows a fifth grade unit where investigations involve measuring plant growth, investigating insects, and reading with partners and as a whole class. Let's see how investigations play out in Unit 1.3. In Lesson 2, we revisit those prediction sticky notes that we posted at the end of Lesson 1 on our sun observations chart. We notice that we do not all have the same predictions for where the sun will be in the morning. Our sticky notes for predictions are in different places. When we discuss our ideas as a class, we realize that we have different predictions for where the sun will be at other times of day too, like at lunchtime or the end of the school day. We use these differing predictions to co-construct our lesson question. Where is the sun in the sky throughout the day? We update our sun investigation plan from lesson 1 by adding the different times of day that we want to make our observations, morning, midday, and afternoon. And we add that we should definitely use the ground-based reference points that we figured out in lesson 1. As we carry out our investigation in lesson 2, we go outside to observe and record the sun's location in the sky in the morning, at midday, and in the afternoon. Each time we return inside, we place sticky notes on our sun observations chart to show where we observed the sun in the sky, and we come to agreement on a class consensus observation. At the end of our investigations, we compare these consensus observations to notice the sun appears in different locations in the sky in the morning, at midday, and in the afternoon. We record this on our Growing Ideas chart, which is a tool we use to keep track of what we're figuring out and our evidence in each lesson. Though we have observed the sun in different locations in the sky at different times throughout the same day, we realize we still have questions. Like, we aren't sure if these different locations happen every day. Would the sun only be in these locations today? Or would we observe it in these locations at these same times on another day? Would they repeat? This is what motivates our lesson 3 work. Do the sun's different locations in the sky repeat? We use our sun investigation plan and go outside to make and record observations of the sun in the sky in the morning. We add a new consensus observation to our sun observations chart and pause to compare this morning's sun observation with the recorded consensus morning observation from lesson 2. Interestingly, our observations don't lead us all to the same claim about our lesson question. We use a voting chart to surface that some of us think yes, the sun's different locations in the sky repeat, but some of us think no, and some of us are not yet sure. So we decide to use a book about how scientists make claims and use evidence to support them. And we find out that scientists use lots of evidence to support their claims. So we decide to gather more evidence by making additional observations of the sun's location in the sky on an afternoon. This evidence will help us better decide if the sun's different locations in the sky repeat. So we make more observations of the sun in the sky on another afternoon, revisit our votes, and make a claim using evidence. The sun's different locations in the sky repeat. We connect the word repeat to the science word pattern and describe the pattern we have figured out so far. Over and over again in the morning, we observe the sun in one part of the sky, east. And over again in the afternoon, we observe the sun in a different part of the sky, west. We feel really good about what we figured out about the sun's different locations in the sky in the morning and afternoon, but we also realized that it would be really helpful to know where the sun is in the sky at different times besides just morning and afternoon. This would help us figure out our lesson set question about how the sun can be in our eyes sometimes, but not all the time. This leaves us wondering what happens to the sun in between the locations we have observed it so far. So we start lesson 4 trying to figure out what happens to the sun in the sky between morning and afternoon. We decide to investigate using photographs of the sun in the sky at different times of day, taken in different locations. We have 4 different sets of photographs. With a partner, we make and compare observations of the sun in the sky using one set of photographs, and then we use a version of each set to compare and discuss as a whole class. We figure out that the sun's changing locations in the sky repeat over and over again on different days and in different places. The sun is lowest and farthest east in the morning. In the late morning, the sun is in between its morning and midday locations. It is highest and in the middle at midday. In the early afternoon, it's in between midday and afternoon, and the sun is lowest and farthest west in the afternoon. We're still wondering, though, about the sun in between those observations. So we use a time-lapse video to observe how the sun seems to move across the sky. We add the patterns that we have figured out to our sun observations chart using labels and arrows. Over and over again, the sun appears to move in an ongoing path, rising in the east, moving up and across the sky, and setting in the west. Finally, we read a book about how patterns in science are based on many, many observations, and they are useful because they can help us know what will happen next. We leave lesson 4 excited about using the patterns we have observed and described to figure out where the sun will be next. At this point in the unit, we are ready to take stock of what we figured out so far. It's time for a putting pieces together lesson. In this next lesson, we'll be able to connect the ideas we figured out from the last several lessons and see if we've answered our first lesson set question. How can the sun be in my eyes sometimes, but not all the time? We start this putting pieces together lesson, lesson 5, by drawing on where we ended our last lesson, recognizing that patterns in science are useful because they can help us know what will happen next, and wondering, how can we use patterns of the sun's changing locations in the sky to know where it will be next? We play the sun game, using patterns of the sun's location in the sky as evidence to support claims about where the sun will be at a certain time. Then we draw and write individual claims about the sun's location in the sky in the early morning or late afternoon. Then we use the sun's patterns to figure out where and when the sun is likely to be in our eyes, answering our lesson set question about how the sun can be in our eyes sometimes, but not all the time. Earlier, when the sun is low in the east, and later, when the sun is low in the west, are times when the sun is likely to shine in our eyes if we are facing that direction. Finally, we read a book connecting us to people and animals who notice and use the sun's patterns to find their way. As we navigate out of lesson 5 and lesson set 1, we return to our notice and wonder chart and our experiences chart to realize we've addressed many of our questions and experiences about the sun in the sky, but we still have questions and experiences about other objects in the sky, like the moon and stars. We review existing questions and also add new wonders, culminating in the co-construction of a lesson set 2 question. When and where do we see the moon and stars in the sky? And this is where we'll turn it over to Sarah to introduce lesson sets 2 and 3.
Thank you, Christy. My name is Sarah Stultz, and I'm one of the writers on Unit 1.3. And I'm going to walk you through the rest of the unit. So as represented in this OpenSciEd instructional model, we now move back into investigating for lesson set 2 in Unit 1.3. So in lesson 6, we decide to investigate the moon in the sky, wondering if it appears to change locations in the sky. And if so, how? We realize we have a lot of experiences investigating the sun's location in the sky from lessons 2 through 4. So we return to our sun investigation plan to help us consider how to plan and carry out a new investigation related to the moon. We decide, like we did in lesson 4 with the sun, to use images of the moon in the sky at different times in order to gather evidence about if and how it appears to change locations. We make and compare observations of the moon in the sky using image cards, and we record these on a moon observations handout. Our observations help us figure out that indeed the moon does appear to change locations in the sky. We use a gallery tour to compare all of our recorded data, our handouts, and we observe that over and over again, the moon first appears lower in the sky in the east, then up high in the middle of the sky, and then lower in the west. We also use a time-lapse video to determine how the moon seems to move in between these observed locations and compare the moon's ongoing path with the sun's to figure out that the moon appears to change locations in the sky just like the sun. At the end of lesson 6, we read a book to connect with an expert who takes photographs of the sky, and we find out how she observes the moon. Looking at her photographs, we observe the moon in a blue sky, as well as a light purpley sky. And many of us find this very surprising. We wonder if the moon is out in the daytime. So we ask some new questions about the moon and other objects in the sky, like stars. And how can we know if we're observing daytime or nighttime skies? And this leads us into lesson 7, which is another putting the pieces together moment through which students can take stock of their learning and they can work together to develop an explanation for our second lesson set question. When and where do we see the moon and stars? We begin lesson 7 revisiting our notice and wonder chart from the end of lesson 6, and we co-construct our lesson question. What makes it daytime or nighttime? Building on the experiences with the moon in the sky from our last lesson, we begin by making observations of new images of the sky in which the moon is visible. We make claims about whether we think our image is of a daytime or a nighttime sky, supporting these claims with evidence from our images. As a class, we build a daytime and nighttime evidence chart. This chart helps us figure out that actually, the moon is not evidence for whether it's daytime or nighttime. We can observe the moon in skies that we claim are daytime skies and those that we claim are nighttime skies. So we recall our scientists make claims and use evidence book and other experiences in lesson 3 to help us decide that we need to make additional observations to gather more evidence to help us answer our lesson question. So we make observations using a new set of images. We organize our images using initial claims about daytime and nighttime, and we continue to add to and update our daytime and nighttime evidence chart. Through listening actively to each other and using evidence to agree or disagree, we eventually decide that the sun in the sky is the best evidence for it being daytime, whereas the sun not being in the sky and or the stars being in the sky are the best evidence for it being nighttime. We connect what we have figured out in this and the previous lesson to answer our lesson set question about when and where we see the moon and stars. And we individually support claims about nighttime using the best evidence. Again, as we navigate out of lesson 7 and out of lesson set 2, we return to our notice and wonder chart and our experiences chart. And we realize we've addressed many of our questions and our experiences about the sun, the moon, and stars in the sky, but we still have unanswered questions, as well as experiences about evening events happening in the daytime and nighttime. We return to the lesson 1 book to identify that in the book, one of the evening walks is happening in the daytime because we can observe the sun, but the other is in nighttime because we cannot observe the sun. So we construct a new lesson set 3 question. How can evening events sometimes happen in the daytime, but sometimes in the nighttime? As represented in this OpenSciEd instructional model, we move into investigating for lessons 8 and lesson 9. In this third lesson set, investigation lessons, students continue to engage in science and engineering practices with a strong emphasis on SEP 5 using math and computational thinking. They continue to collaborate as they consider how to use data, and the teacher provides students with space to grapple with and engage in multimodal sense-making. In Lesson 8, we lean on the ideas about daytime and nighttime that we figured out in Lesson 7 to generate a lesson question related to how long daytime and nighttime are and whether they're always the same. We use our experiences investigating the sun in the sky and our sun observations chart from lessons 1 through 5 to identify that the data we need to address our lesson question are sky observations that show when the sun is in the sky, when it's daytime, and when the sun's not in the sky, nighttime. And we don't have that data ourselves, but our teacher shares with us data that another first grade classroom has gathered. And we use 2 different days' data, day A and day B, and count the number of hours of daytime and nighttime on each day. We compare the hours and we make a class graph in order to further compare and analyze the daytime lengths on the 2 days. We figure out that daytimes and nighttimes are not always the same. Some daytimes and nighttimes are longer. They have more hours than others. Finally, we read a newspaper article sharing additional observations made by the other first grade classroom. This helps us figure out that earlier sunrises and later sunsets cause daytimes to be longer, while later sunrises and earlier sunsets cause daytimes to be shorter. So we add these ideas to our graph. We leave Lesson 8 with questions about, well, when? When did these 2 days that we investigated in this lesson actually happen? Were they at different times of the school year? Are sunrises and sunsets different at different times of the year? And that's where we begin Lesson 9, trying to figure out, when are daytimes shorter or longer? We are able to use more sky observations from the other first grade classroom, these providing data for a day in each month. We individually analyze the data for one of these months by counting and coloring the hours of daytime. And then we combine them into a class monthly daytime graph. We use our graph to compare the number of daytime hours and the length of daytime, as well as when the sunrise and sunsets occur across all 12 months. We use an infographic to relate our data to seasons. And we figure out, wow, this pattern repeats every year. We figure out daytimes are longer, they have the most hours during the summer. And this is because sunrises are early and sunsets are late. And we figure out daytimes are shorter, have the fewest hours during the winter. This is because sunrises are late and sunsets are earlier. As we end Lesson 9, we generate some ideas about how an evening event, like evening walks to the playground, could sometimes happen in the daytime, but sometimes in the nighttime. And we head into Lesson 10 with some new questions that will lead us into putting all of our pieces together. Like other putting pieces together lessons in 1.3, students connect what they have figured out across multiple lessons and apply their ideas to unit phenomena. In this case, they're able to take stock of their learning and work together to answer the Lesson Set 3 question. How can evening events, like evening walks, sometimes happen in the daytime and sometimes in the nighttime? We begin Lesson 10 by revisiting times of day, specifically morning, midday, afternoon, and evening. And we add these to our Day A and Day B graph from Lesson 8. In this way, we figure out, morning and evening are times of day that can happen before or after sunrise and sunset, depending on the season. Using our graph helps us put together all the pieces we figured out in Lessons 8 and 9 to notice that seasonal patterns of sunrise, sunset, and daytime length make it so that morning and evening are times of day that happen in the daytime in the summer, when the sun rises early and sets late, but they can happen in the daytime or the nighttime when it's winter. We use these seasonal patterns to play the seasons game, and we support claims about what season a specific morning or evening event will occur. And then we make individual claims about the season in which an evening event occurs in the nighttime, using the seasonal patterns as evidence. We conclude the unit by returning to our experiences chart, and we get to play the seasons game with our own examples. I'm going to pass it back to Christy here to go over the key features of this unit.
Yay, thank you, Sarah. Now that we've overviewed that storyline, we'd like to highlight a few things we think are really important and meaningful in the unit. One of the things we want to elevate is the substantial use of the cross-cutting concept of patterns in this unit. Students observe and describe patterns in their observations and are then able to use those patterns as evidence to support claims about predicted or future events. In lesson sets 1 and 2, these patterns are about when and where we can observe the sun, moon, and stars in the sky. In lesson set 1 specifically, we use our many observations of the sun's changing locations in the sky to describe patterns that we can then use as evidence to support claims about where the sun will be located in the sky at a certain time on any day. And our sun observations chart on this slide represents how we can use these patterns as evidence. Furthermore, in lesson set 3, as represented on the day A and day B graph, we are able to use the seasonal patterns we describe using daytime and nighttime data as evidence to support claims about which season a specific morning or evening event will occur. In lesson set 3, specifically lessons 8 and 9, as Sarah described, students utilize math concepts to make sense of data about the length of daytime and nighttime and how these vary seasonally. They use counting and numbers, displaying the data using graphs in order to identify and describe seasonal patterns in daytime length caused by those earlier and later sunrises and sunsets. Additionally, across the unit, students engage in the science practice of argumentation. Students use evidence gathered through investigations to make and support their claims. They actively listen to each other's claims, agreeing or disagreeing using evidence, and they are also able to analyze why some evidence is relevant to a scientific question while other evidence is not. And the teacher guides provide teachers with support and guidance for this important scientific work. Next, we'll briefly overview the standards for Unit 1.3 Sky Patterns. The unit builds toward 2 Earth and Space Science, or ESS, performance expectations. 1-ESS1-1, use observations of the sun, moon, and stars to describe patterns that can be predicted, and 1-ESS1-2, make observations at different times of year to relate the amount of daylight to the time of year. Unit 1.3 intentionally develops 4 science and engineering practices, meaning that these practices are used by students repeatedly and with increased independence throughout the unit. These include planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, and engaging in argument from evidence. And as highlighted earlier when we discussed key features, Unit 1.3 intentionally develops the cross-cutting concept of patterns, working to make observing, describing, and using patterns explicit and useful for students. Here, we'll pass it back to Janita.
All right. Thank you so much, Christy and Sarah. That was fantastic, and I'm sure so helpful to teachers that watch this webinar in preparation for teaching this unit. So I want to tell you about a couple of additional resources that we have on our website for you. So these can all be found under the professional learning tab on our website. There you can find opportunities for professional learning and you can sign up for those events. You can also join our new Facebook community. We now have a Facebook group per grade level in elementary. This is a great place to ask questions and learn from fellow teachers and educators that are also implementing our units. And again, this under our on-demand teacher support library, you can find webinars, documents, and other supports for elementary. Know that we are working this fall to build up that library so you can find many resources that can help you during instruction. And we thank you all for being with us today. Please let us know if you have any questions. You can find our contact information on our website.